Thank you, Mark. Good afternoon, everyone. Carlos Romero. I have a couple of challenges today. Number one is to follow up great technical and in-depth presentations from today. It's not going to be easy, probably won't make it. And the second is I need to make sure I don't hold you too long here so that you guys can get ready for the Harry Potter attractions later today. So let's get started really quick. We're going to talk about the energy enterprise as the platform to support the energy transition. We have heard throughout the day all the different conditions, market trends, and different challenges that are coming up for the energy transition, and we need the right tools to be able to support this process. So we'll talk about three things today. The first one, I'm going to start telling you what it is, the energy transition. So if you need to leave right after that slide, then you got like about 90% of the presentation on that first slide. The rest is just going to be fill in. We're then going to go into the why that's happening. Why do we need to talk about that energy platform when we've been operating the electric system for a couple of hundred years? And then we're going to talk a little bit about how we'll get there and the benefits of getting into an energy enterprise. So let's get started with the first one. So the what. So let's define what the energy enterprise is. So the energy enterprise starts with the data. So the first thing we advocate in an energy enterprise is that you have the ability to bring all the data for all the different type of assets that you have into a single platform. You need to be able to bring your power data, your generation, transmission, gas, renewables, advanced technologies that are coming online, things like hydrogen, demand response, electric vehicles, vehicle to grid, and so forth. So we need the ability to bring all that data into a single system. You also need to have the ability to bring that data into multiple time horizons. So you need the data that is going to support your long-term processes, mid-term processes, and short-term processes in your system. So the time of working in silos where different business units have different types of data for doing long-term analysis versus short-term analysis versus medium-term analysis are kind of over. You need to be able to have consistency across those different time horizons and across different commodities. The other element that you need is you need the ability to bring two main elements that will affect that base data. The first one is constant updates to that data that you're collecting. So your base data is right here. You need the ability to bring constant updates to those different data elements that you have there. You need also the ability to integrate those data elements to in between different commodities to create correlations and to construct scenarios that are common across multiple data elements. So for example, you may have the load information about your electric system and your gas demand system, and then you need the ability to create correlations between your gas demand, for example, and your electric demand, and keep that correlation across multiple time horizons and across multiple commodities. But then also you need the ability to bring different type of scenarios that will modify that data. And those scenarios need to have a level of consistency. So it doesn't make sense that you work with some extreme weather cases in the short term, but you don't apply those same kind of weather changes in the medium to long term ranges. So you need to have that ability that those scenarios are consistent across commodities and across different time horizons. And you also need the ability to bring external, not only external data, but also external information, especially for external stakeholders. So you may have people that want to provide additional input and information into the scenarios that you're building to be able to agree that those are the future visions that they have of the system. The other element is you will build your models, and you need to be able to build those models on top of the base data that you have and the scenarios, and have those models available to multiple stakeholders within the organization so that people don't have to be constantly be rebuilding these models on every single business unit, every single department. And then you need workflows. You need workflows that can be consistent across business units, and also within a business unit across multiple time horizons. So the people that are doing mid-term analysis and the people that are doing short-term analysis and long-term analysis, they have some sort of a commonality across the different type of workflows that they can do and being able to incorporate that. Then you need to have powerful insights and advanced analytics. So solutions like Plexos used to be really good at helping you make market simulations, model the market, and get insights into what the future is going to look like. But now we possess technical tools that would allow us to have better insights into what data is telling us, using artificial intelligence, machine learning, other kind of technologies that we want to apply, being able to drive quick insights. So being able to have all the data, all the data types, multiple scenarios, and then being able to highlight specific insights that are very powerful. So point in case, one thing I particularly like to demo when I'm talking to customers is on our congestion analysis tool, where in a simple graphic, really quickly, you can identify within any time horizon, let's say a year, you can identify quickly what transmission lines are congested and the relative size of that congestion compared to the other ones in a single map. The first job I had when I came out of undergrad as an electrical engineer was in transmission planning, trying to determine those kind of things. That sort of analysis would have taken me several days to perform using multiple tools, imports from spreadsheets, working with different counterparts to be able to get that information. Now you can see that information in a map really quick, just with a click of a couple of clicks of a mouse. Those are the kind of insights that we can derive. But also more importantly, now with advanced analytics, you can also determine what are the things that you need to do or should do to prevent that kind of negative impact of those congestion elements, for example. So those are the kind of things that needs to be considered. And last but certainly not least, the reporting. Being able to have a reporting support platform that can take advantage of all this information and processes that have been put together and report the data in a way that is meaningful to the target audience. So if you're going to report to an executive, you don't want to send hundreds of pages of Excel printouts to that executive. You probably want to share a particular dashboard. But if you're going to share that information with another analyst, you probably, a single dashboard will not do the trick. You probably need to send additional information. So those are the kind of things that we mean by having a specific type of reporting that you need to do. The other element of an enterprise platform is the collaboration that must exist across all different business units and across all different departments. In addition to that, integration. So the ability to integrate this system to other systems within the corporation, financial systems, customer information systems, plant operations at the plant level, and other kind of elements. And last but certainly not least, security. So a platform that can be secure, can be reliable, can promote business continuity, but can also be protected from cybersecurity threats. That's what we mean by the energy enterprise. So it's a system that is contained, that can be delivered at the enterprise level to satisfy multiple internal and stakeholders within the energy enterprise for all their forecasting and simulation needs. And that's the definition. So that's what's the energy enterprise. Now let's talk about why we're even talking about this. Why is this relevant now, again, when we have been doing this one way or another for the last couple of 100 years, and the system is sort of worked properly because lights are still on and we all have electricity. So let's look a little bit at why, what are the disruption factors that have come into this element. The first one, and again, this is not new, is that the planning processes that we are talking about are not simple, they are not independent, they are not isolated. These are correlated processes that we have. So when we're talking about the market, and in terms of market analysis, there are all kind of different use cases and business processes people do on a daily basis. And those processes can go from next day to the next 30 years. When we talk about the portfolio system, when you're looking at your own portfolio, we can look at things in long term, meaning 10 to 45 years into the future, mostly around IRP and capacity expansion type of analysis. Then when we look more into the shorter term, we look at medium term processes, maybe next year to the next 5 to 10 years in terms of risk analysis, PPA modeling, budgeting, and so forth. And then when we look more into shorter term, we get more into the kind of the next day, next hour, all the way to balance of the month, maybe balance of the year type of analysis. And then we get more into the real time, all the way up to after the fact. These are processes that are interrelated. These processes touch each other and exchange information. But more importantly, all of these are part of the planning and operation processes of the enterprise. So trying to work these things individually and just concentrated on doing one thing here, isolated of the rest of the system, is really not very productive. And that's what happens when upper management requests certain type of reports. You need to get reports from people in different departments that are using different tools, different formatting. You need to aggregate this information. Some of this information that you are receiving, the outcomes of those processes, come from different input data, from different assumptions. And now you're trying to make sense of a forecast when some of the people use gas at $5, other people use gas at $3. Other people didn't think we were going to use gas, and then you try to put together these reports and deliver it to the decision makers. You have a problem trying to justify some of the information. Also, when you have to justify this to regulators and the external stakeholders have some questions around this, you can have some challenges. The other element is the planning process has evolved. So used to be the planning process is people that tend to use production cost models. It was a single group of people in the basement of the corporation, and they crunch the models, deliver the numbers, and that was kind of the whole planning process. The planning process has evolved and it's a little bit more complex. It starts with the input of the data, and hopefully with the proper tools and the proper interfaces to manage that data. It goes into the scenario development of that data with the market analysts and the internal stakeholders that can participate in that process. Goes into the modelers, the people that are putting together all the different modelers. Then into the analysts who perform the first set of analysis. They may go back into the scenario development people or the data analysts and reward some of these processes, or back to the modelers and have this process going on until finally they get acceptable results provided to the senior analyst that provides more insights until finally gets to the decision makers. This is a circular process that repeats for each one of those components that we talk. So people doing fuel budgeting, they probably have to do this. People doing IRP, they'll probably have to do this. So you have all these different kind of workflows for different business units. And at the end of the day, all of it is part of the same energy enterprise. So one of the ideas is that by deploying that energy enterprise, you can speed up this process, make it more efficient, reduce the probability of errors, and also centralize the information in a way that is more consistent across the different departments. The next thing is, this and the previous slide, again, are things that are not necessarily changing dramatically from what used to be a few years ago, but there is a need now to make it better and to make it more integrated. And why is that? Basically because of this. So we're not going to have the time to go over this. This looks really crowded and really confusing, and it's in that particular format for a reason. So this is Sankey diagram that I plagiarized from a couple of different sources, and then I put my own input, and I was a little arrogant trying to modify some of these assumptions and outputs. But what this Sankey diagram is saying is, by 2050, this is again a very arrogant view of what we think is going to be the primary sources, both of energy and water, and what will be the final uses of these energy elements. And again, it's simplified to some level, but it shows at some aspects of detail. And one of the main things is that when you used to look at Sankey diagrams before for the energy system, it was pretty much just energy. Well, now we have to put other things, including water. One of the previous presentations earlier was discussing hydrogen, and there was a question, is there enough water to support that kind of hydrogen growth? And as we look into hydrogen, we need to make sure that we have enough water for thermoelectric cooling, for any kind of fossil generation that we're still going to have in the system, for hydrogen, as well as other kind of elements that we're going to need the water. We see some changes on the primary sources of energy. Some of them will still remain, like oil It's going to be hard to go completely to zero in 50 years. A lot of it is still going to go into transportation, but transportation, there's going to be a big chunk that will come from other sources. The point is that modeling the energy system is becoming harder and harder. And what Benson said earlier, a few minutes ago, is the forecast that we're trying to do to the future, we've been getting it wrong. So now imagine how wrong we're going to get it between now and then. So the level of complexity is growing. We cannot have the same business processes we have in the past. So we need to improve in the way that we do that. And that's the reason we're talking about this. Also, what made that Sankey diagram so complicated? Well, we are facing some global drivers today. There are two main global drivers that we have today. The first one is what we call Industry 4.0, that most people call the digital transformation. It's basically now we have technology and devices that can read data in a near real-time basis from multiple sources, and we now have the ability to collect the data very fast and abundantly. The second element is climate change. And we're not going to argue here whether this is human cause or not, or who is at fault or who is not, or whether this is just a natural occurrence. The point is that there are extreme weather events that we're subject to that we need to be accounting for. So these two main global drivers have given birth to a number of initiatives and consequences that are taking place in the marketplace today. And we can categorize those in three main groups. The first one is around energy security. So it has to do, with decarbonization. And it has to do with how we model extreme weather events, regulatory changes that are either incentivizing or penalizing the use of fossil generation, the infrastructure decarbonization, which is how much fossil or firm capacity we can take into the system, while at the same time we're trying to put variable energy resources into the system. Electric reliability impacts and how we can make the system not only economic but reliable. And how do we manage the vastly increased energy costs that we're seeing in the system? So as we go into this energy transition, not only we're affecting reliability, and we need to reinvent some of these reliability metrics, but we also see a major impact on production costs that is having an impact in society and the economy in general. So the first thing is decarbonization. The second is energy security. So we're seeing things on supply chain and energy security uncertainty. Supply chain are things like a lot of the materials that are needed, or the minerals that are needed for clean energy deployment, like solar panels, windmills, electric vehicles. These kind of elements require certain materials that are very hard, very expensive, and very dangerous to mine. Those materials create a risk on supply chain. The other thing that we're seeing, for example, with the IRA Act, is that the main purpose of that was to promote renewable generation and help combat inflation. Well, what we're seeing is that everybody wants to get a piece of it, and because of that, everybody is requesting new projects on solar and batteries and wind. And this is driving the price, the cost of these assets a lot higher than expected. So there are a lot of elements related to supply chain. And in terms of energy security, the ability to have secure those main sources of energy. And if we see, for example, what happened in Europe with Russia and Ukraine, how weak the system could be in terms of who your main providers of that first fuel or source of fuel are. And the last one has to do with digitalization. And the digitalization, we see business model disruptions, cybersecurity threats, and customer behavior changes. So we're seeing customer behavior changes in different aspects. The first one, we're seeing, obviously, the load is changing, and the type of loads that we're seeing now, or the growth of the load, is going to be coming from things like Bitcoin mining, load data centers, and those are the kind of loads we didn't used to have before. We can expect that over the next 20 years, we're going to see new type of loads that we didn't expect were going to happen that will have an impact on the system. But also, we see people more engaged before. For most of us, when we grew, well, I'm probably one of the older ones here in this room, but when I was growing up, not many people knew much about electricity, just that you flip the switch and the lights are on, and you turn it off and the lights are off. But now people are much more engaged with what they want to do. So they have Nest thermostats at home. They have solar panels. They have electric vehicles. They have an app on their phones to be able to manage their energy system at home. So those customers are becoming a lot more interactive. And that's making that a little bit more complex. It's good because it brings more efficiency to the demand side, but it's also creating complexities in how we handle that. And then all those consequences have led to many energy customers to create initiatives on how to maximize the benefits of these or to countermeasure the challenges that they will see. Finally, with these initiatives, we see that in the future, could be the next 10 years, the next 15, 20 years, we see a number of elements that will be key in terms of describing the energy system of the future. So the first thing we see is that the energy industry of the future will be a lot more co-optimized, meaning that we will consider the energy system in its entirety, and we're going to model that system completely. So gas, electricity, within electricity generation, transmission, distribution, electric vehicles, and transportation, all these elements will come together. The second element is a highly diverse energy matrix. So we're going to have renewables, we're going to have energy storage systems, gas, hydrogen, nuclear in different forms, conventional nuclear as well as small reactors, biomass, geothermal, and other sources that we're yet to start working on. It's going to be an energy system that is going to be based on low emissions, both for sources and uses. So that's going to be another key element of that future of the energy. It's going to be a lot more sustainable, and it's going to have an impact on energy efficiency and the transportation migration. The next element is we're going to have very active prosumers. So we were talking about people having distributed energy resources, microgrids, self-healing grids, virtual power plants, and so forth. And last, it's going to be a more highly predictive and analytical-based grid. So we will be able to have a lot more devices deployed on the field. We will have ways of measuring what the consumption and the uses of the energy in general is, and we will be able to track that a little bit more. So to do that, to get to that future state of the energy grid, we need to consider three pillars: the data, the technology, and the business processes. And that takes us to our last section. The how we're going to get to that level. So for the how, I would propose, and again, this is just my view of how we can help people get into that particular level. I'm going to propose that we have this octagon, and each one of the vertices, we're going to put one of the key elements that will get us to that future state of the energy grid. So we're going to need to have coupled systems for optimization, meaning a model that can co-optimize simultaneously different type of commodities together: gas, power, energy, ancillary services, electricity, water, and so forth. So we need to have that capability. The second vertex is the ability to manage and to properly model uncertainty. So we see that a lot of the things that we're talking about require a high level of stochastic modeling to understand what-if scenarios. So we don't know exactly what the load is going to be, so we need to apply some correlations to weather and other kind of variables that can impact that. Also, we don't know exactly how much wind we're going to be able to get in this particular region. Therefore, we don't know how many megawatts we're going to be able to produce from these assets. So we need to apply some Monte Carlo and stochastic capabilities to that. So we need a good ability to model uncertainty, but not only uncertainty, but also correlation. Be able to correlate multiple variables together. To do that, we need high performance. So trying to do this in your laptop is not going to be conducive to a good business practice. So you need the ability to have access to state-of-the-art hardware that would allow you to model those coupled systems in those uncertainty models. The next element is enterprise collaboration. Again, the days of having just a few modelers working on a basement and be able to crunch the numbers in a way that makes sense are over. You need more people coming together, people from different systems. If you're going to have the technology that allows you to co-optimize, you need to have the people that will be able to collaborate together across all these different business units in a more synergistic way. You need to have advanced analytics, things like machine learning, artificial intelligence, and other kind of techniques that will be coming really soon. You need to have the ability also to model across multiple horizons. Again, those days where people were modeling long-term with tools, data, and scenarios that were completely different than people in the midterm and the short term, those days are behind us, because you need the ability to have that consistency. It doesn't make any sense that you forecast and you make your multi-billion-dollar investments using certain kind of scenarios and models, and then at the time of operating these assets, you use completely different data that is not correlated. Now, information changes over time. You just need to have the ability to bring that new information constantly, so you're updating that data that needs to be correlated across multiple time horizons. The next one, you need to have the ability to what we call the digital twin. And again, when I started working on this, and Benson was referring to how you model combined cycles in the past, et cetera. I remember the first production cost model that we worked on. The way that we will model combined cycle was extremely simplified. And the way that we model hydro systems was also extremely simplified. Because for the most part, they couldn't get it wrong. And also there was no technology to make it more realistic. But today, you really need to be able to model in your production cost models the assets, the way they behave in real life. It doesn't make any sense to say, oh, let's just ignore heat rates, or let's ignore ramp rates, or let's assume that chronological constraints don't exist, and let's see what happens. Yes, you're going to get a faster answer, and probably an answer that makes sense with your conventional wisdom, but it's not going to be the right answer that you need. So you need to be able to model assets the way they behave in real life. And last, you need to have consistency across your market and your portfolio fundamental data, and the ability to aggregate this data and manage this data in an updated and frequent manner. And then having this access, then do kind of a self-evaluation. Where do you think you are on each one of these things? So do you have a model that really replicates what your assets do in real life? So if the answer is absolutely yes, you put it here. If it's not, over here. And somewhere in between, you try to put it. And you create this radar map that is going to give you a little bit of an idea of where you are. So let's look at some examples of what that could look like. These are actual customers. Obviously, I'm not going to say the names, but actual customers I have the opportunity to meet with over the last few months, where I've been able to ask these type of questions, and we've been able to draw these maps. As you can tell, this is almost like if people says, let's go ahead and get on a diet. Everybody's going to start on a different point. Everybody's going to have a different sort of enthusiasm and energy to get into a particular diet or something like that. With the energy enterprise, it's not going to be simply just deploying one product overnight and then you are on board. You need to do a number of different things. But this is a good way to establish a baseline of where you are and where you need to be in the next year, next 2 years, next 5 years, and then create probably a plan of how to get there. So the invitation is for people to do an evaluation and see where you are on that and what could be next. And why doing that? Not only because you have to, otherwise you're going to get it wrong, but some of the benefits, obviously, is to have a least expensive energy transition. We know that this energy transition is going to be very expensive, so let's pick one that is the least expensive. The other element, increase reliability. Manage the risk exposure, improve profitability, and improve your investor relationships. That's a key element that needs to be part of what people need to be considering. We are seeing already that there are a lot of hedge funds and investment bank that are taking a second look at companies that are not getting into this energy transition wagon. And people need to be able to get into this in order to take advantage of these kind of elements. So these are some of the benefits. And I think that's the last slide I have. I just wanted then to open up for questions. And again, I did not want to hold anybody hostage from Harry Potter. So, if there are questions, happy to answer any questions you may have, or I can answer questions when we are at the park. So whichever works for the team. Thank you.